Good morning, students. Welcome to the class of Technomathics. So today we have taken some question from mensuration solid objects. Okay. So in the first question we have taken a question from a cuboid where cuboid is there, and we are going to calculate the when the thickness of this cuboid when the thickness of this cuboid is given. That means a wooden box. Let me read the question first. The first question which we'll take for today is that find the volume of wood used to make a closed box of outer dimensions 60, 45, 32. So this is the wooden box. Okay, for this wooden box, this is made of wood of some thickness. Okay, let us say this is the thickness of the wood. This one is the wood thickness. This is the thickness of the wood. So students, if this is the thickness of the wood, then it has been asked that find the volume of the wood used to make this closed box, right? And the thickness of the wood is given as 2.5 centimeter. 2.5 centimeter is the thickness of the wood given to you, right? So that means if 2.5 centimeter of slab is used to make this box, okay, that would be same 2.5 centimeter over here, same 2.5 centimeter over here, and same 2.5 centimeter thickness over here, right? So we are going to calculate the thick we are going to calculate the volume of wood used. Volume, what is the volume of wood? This is being asked to us. This is the question. Okay, and the dimensions of this wooden box is given to you as 60 into 45 into 32 centimeter. So friends, if these are the dimensions 60, 45 and 32, then definitely this will be the length, breadth and the height of this wooden box, right? So make sure, since this is given that these are the outer dimensions. So these are the outer dimensions. That means from here, the extreme end to this end, this will be the length, right? Similarly, for height, from the extreme end, this one, to this point, this will be the external height. Similarly, it happens for the breadth also here, right? So students, make sure, since this is made of wood and which is having some thickness, right? So definitely this thickness is also considered over here. If you see over here in the length, this thickness is captured over here into the two sides. Okay, if we consider the length, highly good day. Oh, hello. Hi, Hamja. So here I am saying that whenever you are just making a when you are just making a wooden box, this is having certain thickness, and this thickness is, if you are considering for length, this is here also and this is here also. Okay, so this thickness would be carried across. Okay, but I'm just considering for length. So if one of the dimensions is considered, then this 2.5 and this 2.5 centimeter of thickness, okay, this should be considered, that if this is the outer dimension, if this is the outer dimension, this is the outer dimension, I mean to say this is the outer dimension of the box, 60, 45, 32. Then thickness of the wood is given to you, right? Now, what is the volume of the wood is used, which is in making the box? So the volume of the wood, that means the content of the wood. The thickness we need to consider only, right? So here we can see that if this thickness over here is 2.5 centimeter and similarly 2.5 centimeter over here, then from the length, it will be, hi Nora, very good morning my dear friend. So for here, if you consider the length, then the outer dimension will be, the length will be 60, the outer length will be 60, outer breadth will be 45, and let's say the outer height will be like high 32, right? Now here I can see that if 2.5 centimeter is the thickness over here, 2.5 and 2.5 over here, and if you see a box, a wooden box inside the main box, that is made up of made up of air, right? So here the content of the air, which is vacant over here, okay, why I want to calculate the volume of the air wooden box, that means the air of the vacant space, then that box will be having this length of 60 centimeter minus this thickness and minus this thickness, right? So 2 times this thickness will be removed, okay, fine my dear friend. So here, if you reduce the length from 2.5 centimeter, the thickness from one side, similarly this thickness from this side, then 2 times this thickness will be reduced from length, and this will be giving you, 60 minus 5, so that will be giving you 55. So 55 centimeter is the internal space, the length of the box, which is having an some internal space where you can keep some things, where you can just keep some items over here, okay. So I'm just seeing how much space is available to you. So for that internal space, the new length will be 55 centimeter, right? This is, let me say, this is an air box. Air box, why I am writing it? Because the box which is inside this wooden box is vacant, okay. I'm just pre-assuming a space which is available for you to use, right? So the length will be 55 centimeter, right? Similarly, this 45 centimeter, the breadth, okay, the 45 centimeter which was the breadth, okay, this will be subtracted again with here also 2.5 and here also 2.5. So 2 times 2.5 will be subtracted, right? So this will be, I'm just making a demarcation. This will be the new length for the air space, right? The length which is available to us for use is not 60 but it's 55. Similarly, the breadth which is available for us to use is not 45 but the thickness will be removed from both the sides, from one side here and another side here, right? So minus 2.5 and minus 2.5, because this is the thickness. This is the thickness. Okay. If this thickness is 2.5, you calculated it, Harija. Hi, Hamja. Saruk. Sorry, wrongly pronounced. My dear friend. So 2.5 centimeter is the width, then definitely this will be reduced from both the sides. So the inner space, the breadth of the space which is available to you for use is 45 minus 5. So this will be coming as 45 minus 5 is 40 centimeter. 40 centimeter. This is the space available to use, right? This is the new length. This is the new breadth, right? Or I'm writing usable space inside the box, right? Is having the length 55, breadth 40. Similarly, from 32, the height, this was 32, 1 centimeter will be reduced from here. Sorry, 2.5 will be reduced from here and 2.5 will be reduced from here, right? This one. So in this way, the effective height which is available to you is only this much. And this is what? I'm just writing for height. If this is nothing but the height was actually 32. So 32 was there and minus 2.5 centimeter over here. This is, this width is 2.5. 2.5 I am saying. Okay. Similarly here also 2.5 thickness, this thickness. So this will be removed. So 32 minus 2.5 centimeter from the top and 2.5 centimeter from the bottom. So it will be minus 2.5. You have calculated your answer. Hi Nora, thank you so much for being connected. So minus 2.5 centimeter. So this will give you 32 minus 5, that is equal to 27. So 27 centimeter the new height for the usable space. The usable space, that means the box which can be assumed to be seen inside this. And how will be calculating the volume of the wood? The volume of the wood, as it has been asked, it will be calculated. Just calculate the volume of this wooden cuboidal box with this dimension 60, 45, 32, which is the outer dimension. From it, subtract the volume of the usable space box, that is with the length 55, 40 and 27. Then you will get the volume of the wood which is used in making this box. And how we arrived on this new length, new breadth and new height? We just removed and reduced the 2.5 centimeter of thickness from both the sides, two times in length, reduced 2.5 centimeter thickness of wood two times in breadth here, and similarly we removed the thickness of the wood two times, 2.5 centimeter here and 2.5 centimeter here in the height, and the new length, new breadth and new height is 55, 40, 27, right? So let us see, Hamja, whether our answer is correct. So the volume of the wood, the volume of wood will be how much? This will be equal to box volume with external dimension or outer dimension. Box volume with outer LBH, right? The dimensions minus this minus the box volume with inner dimension. So these are nothing but the 45, 40 and 27 are the, which I am written as air. Basically these are the inner dimensions, right? So minus I am writing box volume with inner LBH. That means inner dimension, right? When you just take the volume of the box with outer dimension, right? And from that you reduce the volume of the box with inner dimension, you will get the volume of the wood, right? You will get it, which is required to be calculated, right? So the outer dimension was 60, 45 and 32, right? So the volume of the cube, we know that it is equal to L into B into H. We know the formula, right? So for the outer dimension, the volume of the box will be 60 into 45 into 32. So let me write, that is the box volume with outer dimension. Outer, mind the word. So that means 60, 45 and 32 are the outer dimensions. So 60 into 35, sorry, 45 into 32, right? Box with the inner dimension, that is 55, 40 and 27. That means the usable space which are we going to use, minus 55, which is the new length or the usable length for the box from inside, 55. Then the inner breadth will be 40. I'm just going to calculate the inner volume, 40, right? Minus, sorry, into height 27, right? So into 27. So this will give you the volume of the wood used. Okay. If I am going to calculate 16 to 45 into 32, right? Let me do it. 45 into 32 first, because we can use 0 for this, and that's why we'll do multiplication of 16 to the last. But if you take some common, 27, 45, 60, 20, so we can see 20 can be taken as common, even 9 can be taken as common. So it will be simple. 20 can be taken as common from this, even 9 and 8 can be taken as common, because 20 taken as common from 63 is left. If from 9, from 45, 5 is left. from 8, from 32, 4 is left, right? Minus, minus what is there into the all answer is coming as 594. So let us see whether that answer is correct. Okay, if that answer is correct, we can see that minus 20 is taken from here from 40, so it will be 2, because 20 into 2 will be 40, and 9 is taken as common from 27, let us say, so that is 3 is left, and 8 from, and 20, 20. So rather than taking 9, we can take 5 as common, and from 5 we have left with 9 over here. 5 into 9 will be 45, and from 5, if this 55 is taken as common, right? So you can do this simple calculation, my dear friends. I am not going into it because this is taking some time. Simply, if you are not able to take common, you can simply multiply and reduce it. Then you will get the volume of the, you will get the volume of the wood over here. Okay, 60 into 45 into 32 minus 55 into 40 into 27, right? You will get the volume of the wood. But I think Nora want me to calculate it, right? So let me do it. 45 into 32, 90, 3, 5, 15, carry 1, 1, 3, so 1, 4, 4, 0. 1440 into 6. So this will be coming as 0, 8640 is the dimension for the outer box, of the wooden box with the outer dimension. So this is coming as equal to 8640, 8640, right, centimeter cube, right? And what is the volume of the box with inner dimension? That is 55 into 40 into 27. So let me do it. 55 into 27, 385. So it is coming as 1485. 55 into 27 into 40. So this will be giving you, when you subtract the outer volume, sorry, inner volume is coming as 145 into 40. So 0 will be as it is, 4, 5, 20, carry 2, 32 plus 2, 34, carry 3. So 8640, and from 61 0 was left. So this is 86400. Okay. So one more 0 will be there. And from here it will be 4, 5, 20, carry 2. So it is coming at 59400. 59400 is the internal dimensions, is the volume of the wooden box with internal dimensions. So I am writing it over here as 59400, 59400, right? So you can see these are the volume, these are the volume of the box with outer dimension, this is the volume of the box with the inner dimension, right? Then what is the quantity of wood that is used? You can just subtract this, then you will get the volume of the wood that is used in making the box, in making this box. If you subtract it, you will get 0, 0, 4 minus 4 is again 0, 16 minus 9 is 7, 7 minus 5 is 2. So 27,000 centimeter cube of wood is used in making this box, my dear friends. Okay, 27,600 centimeter cube, right? You calculated 594 meter square. No, Hamza, this is coming as in meter square because this is the volume, and all the dimensions are in centimeter. So if you are converting it to meter also, then your answer, as you have shown, that 594 meter cube meter square will not be meter square, but it will be meter cube. Okay, make sure that whenever you are just calculating the volume, the unit will be in cube. Okay, why cube? Because you can see length, breadth, and height three times coming. So that means meter, 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 meter cube. Similarly, meter, centimeter, centimeter. So this will be centimeter cube. Though our dimensions are centimeter, so the unit will be in centimeter cube. Similarly for the inner one. So we'll get the answer that this much of wood is used in making this box. Which box? The box which you have shown it. Okay. Now my dear friends, let us take another question for today. Okay. Sorry. The another question for today which we are going to take is from a swimming pool. How much of you love swimming? Any interest from anyone? Just in between, I'm changing the page. I want to understand. No problem. So swimming pool is 260-meter long, 140-meter wide. So a swimming pool is there, which is 260-meter wide in length and having the width of 140 meter, right? So this is a swimming pool. I'm just trying to make it. Don't see it as a parallelogram. It will be a rectangular shape. Okay. So in this pool, some water is contained. Okay. Some water is there inside this swimming pool. Okay. So we need to, if it is given that what is the volume of the water is given to you, the water which is present inside this swimming pool, the water which is present inside this swimming pool, and the volume of that water is given to you. The volume of the water is given to you, that is 54,600 meter cube water inside this swimming pool. So that means if this water is contained in the swimming pool, this swimming pool is also having certain depth. Okay, also having certain depth. If this pool is having certain depth, then definitely this water, as we shown, this water is filled till the floor of the pool. Okay, let us say if this is made up of pool is made up of glass, then you would be able to see exactly the content of the water which is inside this pool, right? So this is also just resembles a shape of a cuboid, isn't it? Here the length and breadth is given to you. The contained volume of the water is given to you. Then we are going to calculate which is asked, that is find the height of the water level. So the height of the water level is this one, right? That means whatever the hypothetical cuboid which you are forming, which is practically lying over here, but you need to observe how. So the height of the water level which you are able to see but not able to measure, that can be calculated very easily. The height of water level. Height of water level we are going to calculate. So inside the swimming pool, have you seen certain labels have been marked that yes, the height of the that is mentioned over there into the pool, that yes, up to this level or that, right? That is the safe limit. What is the height of any specific pool, that is always mentioned over here. Okay, so the height of the water level we are going to calculate. Okay, it's a simple cuboid. Okay, swimming pool is just into the shape of a cuboid. In mensuration, we need to observe that whatever the question which is coming in front of you, that will resemble from one of the predefined learning which you have did. That is, it may be a, if a solid object, then few of the solid objects you have learned. That is hemisphere, a sphere, cuboid, cube, cone, right? Like that, first term. So we need to understand which shape is this. So this is a cuboid, right? And it's given that the length and breadth is given to you. Then it has been asked that what is the height of the water level inside the swimming pool. So to calculate the height of the water level, we need to understand what is the volume, because the volume is volume of any cuboid. You are knowing that it is, this is L into B into H, isn't it? If this is L into B into H and you are having L and B, can you calculate the H? If volume is given to you, that is 54,600 meter cube of water is contained into it, right? If you convert it into meter, it will be 54.6, right? 1 meter cube equal to 1 meter cube is 1000, right? So we can convert it, but that is not required because the volume of the water level is given into meter cube only. So swimming pool volume is nothing but 54,600 meter cube. That is the water contained inside it. This one, right? That is equal to L into B into H. What is L? L is 260 meter. What is B? 40 meter. And what is H? This is the height of the water level. Height of the water level that we are going to calculate. Just keep it as a variable, right? If this is acting as a variable, this H can be calculated very easily if you divide 54,600, this one, by 260 and 140 meter, which is coming from the RHS. So this will be, let me write with my red pen only, 260 meter into 140 meter. So 2 times meter will cancel the meter cube of the numerator and only meter will be left, right? So 54600 divided by 260 into 140. So this will be the height of the water level, right? You can do simple calculation. These two zeros will cancel by these two zeros, right? Yeah, from 13 26 will be divided in 2 times. From 13 this 54 in 13 4 52 26 13 2 26 42. So, and 14 will divide this 42 in 3 times, right? So this will give you 3 by 2, 3 by 2. So h is coming as 3 by 2 meter, which is equal to, which is the value of h, which is finally coming as 1.5 meter. So 1.5 meter is the height of the water level, which is calculated to us. 1.5 meter, this is nothing but 1.5 meter, which is calculated, my dear friends. Okay. So in this way we have solved this question also, students. So for solving such questions, you can easily understand and just correlate that whatever the solid objects which is coming into mind after seeing the object. Okay, just read the question very carefully. You will be easy to understand which formula which we are going to use. If this is a shape of a resembling the shape of a cuboid, just remember LBH is the volume of that cuboid. If any solid object which is given and that is into the shape of a maybe cylinder, that will be equal to volume of that is pi r square h. If it is resembling the shape of a cone, it is 1 by 3 pi r square h. If it is resembling the shape of a cube, that is, this is side into side into side, that is cube. So that all these formulas need to be in your mind, my dear friends. Okay, because in near time you will be having your exams and you should remember all these formulas in your mind. Okay, and how to application of these formulas we can be only understood when you solve multiple question. And whenever you are starting the question to solve, make sure that each line of the question should be properly understood before proceeding forward. Okay, these are the few mantras which you can apply, though I know many of you are expert into that, but yes, you can refer. Okay, thank you so much and all the best, my dear friends.